Alright, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular, the AWD1100 C# Programming Language Fundamentals class, I've been going through a series of video presentations I'm creating based on the book for the class. That book being Murock's C# 2015. Hold on just a sec. Alright, I've been doing some of the taping this afternoon at my home, and the grandfather clock was going off, so that's why I just paused the video for a minute. So far in this book, I have gone through all of Section 1, those 3 chapters, all of Section 2, those 8 chapters, all of Section 3, those 5 chapters, and in Section 4, I've gone through the first 3 chapters. So I'm going to finish up right now and go over how to use ADO.NET to write your own data access code. Alright, which will finish up the database programming section of the textbook. And again, virtually all of the stuff, or at least most of it that we've been writing so far, it's kind of a misnomer. We haven't been writing it. We've been setting things up and letting the system write it for us. Now we're talking about taking even more control over here and writing more and more of this ourselves. So we have, 4 applied, 3 knowledge objectives. Our applied objectives: use a connection to access an SQL Server database, use a data retriever to retrieve data from a database, use data commands to execute action queries or queries that return a scalar or single value, use parameters to limit the data that's processed by a data command. Those are our 4 applied objectives. And as far as our knowledge objective, describe the use of parameters with SQL statements, describe the use of a data reader, describe the use of the 2 types of queries that don't return result sets. Alright, so again, as mentioned previously, you're going to get the 35,000 foot view level here. In other words, I'm going to go over this with 1 or 2, but that's going to be it. Alright? Well, again, that's the problem you run into when you work from home. So this will probably be a very short lecture, and then I'll pick it up again in the next one. So here's some constructors for an SqlConnection, some of the common properties, some of the common values used for a connection string. Notice things, we've talked about these before. The data source, the initial catalog, where does the database live, what's the name, does it have Windows security, do we need a user ID to log in, do we need a password. So here's a couple different connection strings. First one from LocalDB, the second one from SQL Server Express. You'll notice the SQL Server Express is a little more trimmed down. And Jet, which is another data provider. Okay, why don't we just stop it right there. Alright, I'm going to try to continue on. I realize this has been a little bit disjointed, for lack of better words, but I don't think that this is going to take more than 10 minutes or so probably to go through all of it. This is code, as is mentioned right here, that would open right there and close a connection. Now, typically, you always have to open a connection so that you've got access to the database. But typically, if you forget to close a connection and the application ends, it's automatically closed. But it's still considered a good idea to immediately close the application when you don't need it anymore. So here's 3 constructors that you can use for writing a command. Just the command itself, the command plus text, or the command plus text plus the name of your database connection. Some common properties for the class. Again, I'm just going to keep whipping through these. All right, we've got execute reader, execute non-query, and I believe non-query is an execute reader, I believe, is like on a select, and I believe a non-query is on either a create, an update, or a delete. An execute scalar should only be returning one thing. Now, if you are constantly writing the same type of routine, or I should say running the same routine or routines over and over and over and over and over again, you'd probably want to put those into a stored procedure. And really what a stored procedure ends up being is kind of the equivalent of like the reason that you write functions in a C# program. They're kind of the same type of thing, but they're designed to work with databases. So notice we've got code here that creates an SqlCommand object. All right, then it sets up a string that's going to do what? From our customers table, it's going to grab the ID, the name, the address, the city, the state, and the zip, and then it's going to run that command. Now, where's it going to put the results? Wherever the heck we want them to go. All right, as you look on the examples here, what you'll notice is when we use SQL Server and we start to use these parameterized queries, we use @ here. If we're using OLE, Object Linking and Embedding, or ODBC, Open Database Connectivity, then rather than using the @ we use question marks. All right. I don't even know if there's much more in here that's worth going over. We've talked about data readers. All right, and when you execute a data reader, the idea is that it's going to give you a bunch of information back that's going to be read-only. All right. So here we're reading in a list of states, code that creates and executes a command, and then returns an aggregate value. So this, as it says here, is going to give us the sum of all of the invoices from our invoice. All right, and then give us that one sum after we've gone through the entire database and then close our connection. Here's code, as it says, that creates and executes a command to insert a row into a table. So there's a lot of different ways that you can do this stuff, okay? And you might say, well, if the system is set up so that it can write this information for us, why would we ever need to do any more then? Well, again, anytime that you have something like code being written for you, there's a good chance that it won't be one size fits all. In other words, notice what we can do here with this customer maintenance form. If we click add, this should all be blank. If the last record we had in here was 35, let's just say, then if we clicked add, this would all disappear. That would become 36. We could put in information here, click add, and boom, we'd have another record in there. If we put in 35, click get customer, and click modify, then we should be able to change any of these fields. Delete, with that, you should be able to remove, all right, a record. So that's a customer maintenance form. Here's an add modify customer form. Here's a dialog box. All right, you really should always ask the user before you remove something. Are you sure that's what you want to do? Here they're showing what's called a class diagram, and the idea behind this is it is showing for each one of the tables that you have here, it is showing both the field names and any associated procedures that have been written. All right. I may be just about finished here. So again, this is one way that you can do this stuff. I'm not saying it's the only way. I'm not saying it's the best way. All right. Now, when you want data to persist, there's two major ways that you can get it to persist. The first way is what we've been talking about for chapters 17, 18, 19, and 20. And those have involved using a database. There's also another way to get those to persist, And that is through the use of files. So when I come back in Chapter 21, we'll talk about how to work with files and data streams. All right, so I will be back with that lecture in just a couple minutes.